We're going to start with a little review, and then we're going to discuss measures of central tendency in this lesson. Okay, remember in the previous lesson we discussed the difference between a population and a sample. Remember, a population is everybody in whatever you're trying to survey, every college student at a college, every person in a class, every person in the United States. And a sample is just a portion of that, a subset of that. Now, when we're working with statistical information or numeric values computed from populations and samples, we actually call them two different things. So a parameter would be a measurable characteristic of the entire population. So if we're talking about an average of a population, we would refer to that as a parameter. On the other hand, if we are measuring something about a sample, we would actually refer to that as a statistic. And you might remember that the goal of statistics is to help us to infer things, inferential statistics, which is being able to make decisions or inferences or guesses about a population based on a sample. Okay, here we go with the real topic of this lesson, which is measures of central tendency. Now, the purpose of measures of central tendency is to try to pinpoint the center of the distribution of the data. In other words, what's the midpoint? And the four measures that we use for that are the arithmetic mean, the weighted mean, the median, and the mode. And in this lesson, we'll discuss the arithmetic mean, the median, and the mode. The most common measure of central tendency is the mean, and we commonly call that the average. Now, we talked about scales, and the average will require an interval or a ratio scale. And remember the difference between the two? The ratio scale has a true zero, in which zero really means zero. Now, the population mean and the sample mean are actually computed the same way, however we designate them a little bit differently. So here we have a formula for the population mean, and the first thing you want to notice is that we have the Greek u, or mu as it's called, that represents the population mean. And then to compute the population mean, we're going to sum up the values. And you see the summation symbol there, you see x, which represents each particular value, and then we're going to divide that by n. Now in this case we are using a capital N, and the capital N represents the number in the population. So we'll compute a sample mean the same way, but we will designate it differently. Again, a mu represents a population mean. Most of you are very familiar in how to compute an average or a mean, but we're going to go ahead and step through it. So with this example, we'll assume that we are going to compute a population mean. And so this is the age of all of the students in the statistics class. So in this case, the population would be the statistics class. Alright, after we have all the values in the population, we're ready to go ahead and compute the mean. And the first thing we do is we sum up the values, and in this case that comes up to 483. We divide that by the count, the capital N, because this is a population, and we end up with a mu, or a population mean, of 24.15. Now here we see the formula for the sample mean, and it's essentially the same. You sum up all the values and you divide by the number. In this case though, because it is a sample, n is lowercase, representing the number in a sample, and notice that instead of using mu, we use x bar. So x bar represents the sample mean. Now here we have an example of a sample mean, and in this case if you look at the house prices, you can see that house number 7 is kind of way off track. It's it's at the end of the hill, it's in a cul-de-sac, and it's 5 stories and 16,000 square feet, and it doesn't really fit the neighborhood. However, when we compute the sample mean, we would say that the midpoint, or the central tendency in this case, is 201,000, and that's higher than anything else that's even here. So one of the drawbacks of using the mean is that it is indeed affected by outliers, as we see in this case. As we saw earlier, the mean is just one measure of central tendency that we use. Another one that we use is a median. Now the median is the literal midpoint between the values. It'll have an equal number of values above it, an equal number of values below it. Now one of the advantages of using the mean is that it's not affected by outliers, as we saw the mean was. So when you're ready to compute the median, the first step is to actually sort the values in ascending order. And so to illustrate that, I've gone back to the list of student ages in the statistics class. So once they're sorted by the value, in this case age, we're ready to go ahead and go to the next step. The next step is to find the midpoint. the place where there's an equal number of values above and below. Now, in an odd number of values, in this case we have 21 values, it's easy to do that. We find the place where there's 10 values above and 10 values below. So in this case, the median, the middle point, would be 21. And here we see the median with some home selling prices. And again, it is just this spot right in the middle where an equal number of values above it and below it. And like I said, if there's an odd number of values, it's very easy to find that point. Now with this example, I've added a house to our data set, and so we have an even number of houses. It's not quite as simple. There is no one value where an equal number fall above and below. So in this case, we actually take the difference between the two values. So the center point would be between 4 and 5. And so the value for 4 is 112,000, the value for 5 is 115. So we add the two together, divide it by 2, and we come up with the actual midpoint, or the median in this case, of 113,500. The mode is another measure of central tendency. It's very simple. It's simply the most often occurring value. And you can see that what I've done here with the ages of the statistics class is I've created a frequency distribution. And the one that occurs the most, the age that occurs the most, is the age of 20. There are 4 occurrences of that, so that would be the mode. You can see that visually in the column chart or bar chart that I've created below that. And as this slide shows us, we can also have a mode for nominal or categorical data. And in this case, we're simply counting the occurrences of that particular category. And here's another illustration of the mode with the house selling prices. The price that occurs most often is 100,000. So in this case, with this data set, 100,000 would be the mode. As we delve more deeply into Excel, you'll want to pay more attention to the demos that are on this site. But in this case, we can see that the mean, the mode, and the median have very easy to use functions in Excel. And you can see an illustration of that in this slide. But if you also watch the demonstrations that are included in this website, it'll make more sense. As we delve a little deeper into statistics, we're going to be talking about distribution and primarily a normal distribution. And if our data is completely symmetric or normally distributed, the mean, the median, and the mode will all be the same value. Now, as the slide shows you, it is possible for data to be skewed either positively or negatively, and we'll cover that a little bit more in detail as we go.